Hi, welcome back to another episode from Spiral Physics Education. In this episode we're going to be looking at gravitational potential energy in more detail, but what will help you to get the most out of this lesson is having an understanding of stores and transfer, and knowing different examples of stores and transfers. Know the principle of conservation of energy as well, because everything obeys that. And that work is done when energy is transferred between different stores. Not only is it done usefully, but some is also wasted. And remember that there is a nice statement that you can use for exams for this. It says that thermal energy is dissipated to the surroundings. We're also going to be using the equation for mechanical work is force times distance moved in the direction of the force. So in this lesson, we're going to be covering gravitational potential energy, and we're going to be using this equation, looking at a few examples, and right at the end, if you enjoy playing around with equations and enjoy your maths, and you're interested in the origins of equations, and then we'll look at that as well. So, gravitational potential energy, well, put simply, gravitational potential energy is just the energy that an object has depending on its position above the Earth. If we think about it, if we're going to lift an object above the ground, that's going to increase its gravitational potential energy store, but that requires a force. So that means there's a mechanical transfer of energy involved. So mechanical energy transfer will increase the gravitational potential energy store of an object. And we can use this equation to calculate it. So the delta there, we're going to use that symbol to signify that there is a change. So delta Eg at the beginning of that equation, that just means change in gravitational potential energy. And that is equal to mass times gravity times height. Now the units here are very, very important. If gravitational potential energy is to be measured in joules, then mass must be in kilograms. Gravity, well, that's going to be given to you in newtons per kilogram, and height must be in meters. So instead of writing that out, which is quite wordy, what we can do is write our equation in this form. So to say it out in words, the delta there at the beginning means change. So we've got change in gravitational potential energy is equal to mass times gravity times change in height. So let's have a look at an example, and here we've got an example of a mine shaft with a very large elevator involved, with a person that's going to go up the mine shaft. So looking at this straight away, it's quite wordy, and there's a lot of irrelevance in there as well. So it's irrelevant that it's a mine shaft, and whether it's a person or another object, that's irrelevant. Obviously, what you want to do is try and get the important numbers out of the question. So I always suggest to my students that use highlighters or underline or somehow bring out the important parts. So the important part here is that you've got a 65 kilogram person, and you get given gravity, or the gravity here on Earth is given as 10 newtons per kilogram. And also the difference in the height. So the height difference here is 2,283 meters. So the first thing we can do, always write the equation down. You'll get a mark for that in an exam, possibly. And then substitute in the values once you're happy about the values. Checking the units. Is mass in kilograms? Yes. G is in newtons per kilogram. And is the height in meters? Yes. All the units are fine. And multiply those together in our calculator, and we get a nice large number of joules there. So if you're confident with your standard form, what you can do is put that into a bit more manageable number, converting that into 1.48 times 10 to the 6 joules. I would suggest, if you're not confident with your standard form, do some exercises to improve your confidence for the exams. So let's have another look, another example. This time we're going to look at a ball being dropped, and this time the Empire State Building, where there's a viewing platform 320 meters above the ground. So the first thing here, if we just do a mental check across the units, we notice that the mass isn't in kilograms. It's important that it's in kilograms. but it's in grams. So we've got to do a conversion from grams into kilograms. So if we divide this by 1,000, we do our conversion, 0.2 kilograms. Now in most cases in an exam, if you need to convert from grams to kilograms, that's worth a mark. Writing the equation down, that could be worth a mark as well in an equation. Now we can substitute in, is everything in kilograms? Yes, everything in meters, yeah, all the units are right. Plug those into your calculator and we get our kinetic energy, our gravitational potential energy. And the gravitational potential energy store is a decrease because it's falling. So, those are the two examples that we're going to look at for the moment. However, we're going to come into more detailed examples using gravitational potential energy store in some later episodes, so come back to have a look at those. So we're going to look at the origins of MGH, and this isn't necessary for doing GCSE or IGCSE exams, but you might find it useful if you're interested in the origins of equations and like playing around with equations. So if we start off by looking at an object that's been lifted up a height delta h off above the ground, and it's being lifted up by a force mg, i.e. the weight of the object. So if we were to consider the mechanical work being done on that would be force times distance. However, the force here is mg, the weight of the object, and the distance that's been raised is delta h. So if we get rid of the brackets there, we can see that we've gone from work is force times distance to work is also mg delta h. And that's the origins of the gravitational potential energy equation. So I hope you found that useful. Please come back to the channel to have a look at more useful videos on spiral physics education to help you improve your physics and hopefully your grades as well. And I look forward to seeing you next time.